Okay, so let's create some confidence ellipsoids for our miles per gallon example in the Motor Trend cars data set. Okay, so I'm going to fit a linear model where miles per gallon is the outcome, uh, displacement, I guess, and horsepower are the predictors. Okay, and I'm going to use RGL, so I need to do library. You need to have RGL installed. And then you have to do this locally. You can't be using, for example, RStudio on a web server to do this because you need, RGL uses your graphics acceleration from your graphics card installed on, on your computer, so can't really do it in the browser. So you need to be running a local version of R to do this sort of stuff. Okay. Or if you're doing it externally, say on a server, you need to tunnel the X connection or something like that. Okay, so let's open up a 3D window in RGL. Okay, there it is. Oops, not that big. Just resize it a little bit. There we go. Okay, and then I want to plot an ellipsoid of the fit, and it turns out that the function ellipse 3D can just take in the fitted object by itself, and it automatically just takes the first three coefficients and fits a simultaneous confidence ellipsoid for those three coefficients. In this case, we only have three coefficients, so that's fine. And I'm going to tell it I want the color to be red, the blending, that this is not the type 1 error rate alpha, this is the alpha blending for how transparent you want the object to be. In this case, I want it to be about 50% transparent. And I want aspect equal true. That just means how it's going to rescale the axes. So I put it in, and there it is. Okay, so this is now our confidence ellipsoid where displacement is on one axis, the intercept is on the other axis, and the horsepower is on the third axis. Okay, so this is a three-dimensional confidence ellipsoid for those three coefficients simultaneously. So the probability that the three-dimensional point for beta 1, beta naught, beta 1, and beta 2 lies in this confidence region is 95% under our assumptions. Okay, so now we can do this directly. I think we should, given our discussion where we actually went through the definition of an ellipse, we should actually do it a little bit more directly. So beta is now just going to be the coefficients from the fitted values. So let me just show you what the betas are. There's the betas. It's 30 for the intercept, minus 0.03 for displacement, and minus 0.024 for horsepower. And then my sigma is just going to be the variance covariance of the fitted matrix. So sigma is the variance covariance matrix of the beta matrix. So there it is, 1.77. You can see it. Okay, and then n is the number of rows, and p is the number of columns of x. So in this case, it turns out that the specific way that ellipse 3D needs it is it needs the A matrix to be sigma times the relevant F quantile, and then 3 here is from the 3 dimensions. It's from the rank of the test. Okay, so that is there, and I'm really being a little bit inaccurate because this is really A inverse from the notation we were using in the last lecture. So keep that in mind. It took me a little bit of nitpicking to figure this out. Okay, and then if you want the names to show up, you need a vector of the names. Okay, so let's open up the 3D connection. Okay, there that is. And then here we're going to do plot 3D. So it takes ellipse 3D, and then it's taking A, but I think in our definition this is really A inverse. It should be A inverse. Okay, and then you want it centered at my beta estimates. Okay, and in this case my K is the identity matrix. Okay, and then T equal 1 is just saying define the ellipse as the set of points where the ellipse is less than or equal to 1. This time I want it to be blue, and then I want alpha blending to be 0.5, so I want it to be about 50% transparent. I want the aspects so it rescales the axes to look nice to be true, and then this is just setting my label names. And then when I do that, get it up, okay, and there it is. You can see it's the same plot. but now we've directly used the definition of an ellipse rather than relying on Ellipse 3D to do it for us. So that's all that it is, and hopefully now you could use this to do your own confidence ellipsoid, your own three-dimensional confidence ellipsoid, and hopefully you could also do it, find another ellipse plotting program to do two-dimensional ones if you wanted to. But this is, I think, a pretty nice way to visualize a three-dimensional fit. I think the way that I would most likely use a three-dimensional hyperellipse in order to visualize a confidence set would be in the case where I wanted to predict three things and I wanted to see the simultaneous prediction. I think that would probably be the most likely instance where I would use some function like this. Okay, but it's pretty neat. You can impress your friends now by using RGL to create confidence ellipsoids for collections of parameters from your linear model fits.